Hi Year 9, so this video is going to show you how to take your circuit diagram that you were working on last lesson for your nightlight and turn it into a printed circuit board. So this is the actual circuit board we're going to manufacture, solder together in the workshop and build. Now last lesson, if you were here, you should have produced this circuit. If you missed a lesson or it's drastically unfinished or doesn't work, then you can go and find it in the student drive, so it's within Student Tech, Mr. Winter, Year 9 Smart Product Design. I've put a lesson 4 in there, or I will do, and there'll be this circuit in there for you to copy and paste, alright? But it would be better if you can do it yourself. Anyway, if you've built it your own, the first thing I want you to do is check a few things before we convert. Firstly, make sure you've set your battery to 9 volts. Remember, double click if you need to change anything. Make sure this is 1K, this resistor. Make sure this resistor is set to 100 and that you've got rid of the K by clicking the down arrow. And most importantly, make sure these two transistors are the correct models. This one should be a BC108B and this one should be a BFY51. And you change that by double clicking on them and choosing it from the really long list here. Alright, also check it works by pressing play. So it should come on when it gets dark. And now you're good to go. So when you confirm your circuit's alright, you're going to do the following. Firstly, take a screenshot of this. We're going to build up photos of you doing this process, and it's going to be kind of the proof that you did it yourself. So drag a box around it is the easiest way. Right click on one of the components and select copy, and then just go and paste that onto a PowerPoint. Alright, and what we're going to do is build up like a picture history of what you've done. Okay. Alright, good. Now, I showed you this briefly, or might have shown you this, but your first step is we're going to turn this into a computer-generated circuit board, and then we're going to do a version of our own to improve it. What I'd like you to do, please, is don't just listen to me throughout this whole video. Watch a step that I do, pause it, go and do that bit yourself, and then come back, alright? Otherwise, there's no way you'll remember all the steps. Alright, so when you're ready to go, up to the top, Project, Circuit Symbols, Convert to PCB Layouts. Next, single-sided normal tracks. It doesn't really matter what you pick here, but as long as it says single-sided, just next again, you don't need to mess with any of that, and convert. Now what the computer will have done is gone and got all of the components that you need, but the kind of real-life versions of them, and it will try and figure out how best to connect them. Excuse me, just having some coffee. Okay, now what I'd like you to do here is we want to check it still works even though the computer did it. You'll find at the moment if you press play nothing happens, and that's because we need to connect a battery to this. Now a little note on this, a few of you seem to be struggling. You'll notice there are different categories of battery. Alright, you'll see there's PCB components and everything under this has a green background. These are things that solder straight to the circuit board. If you scroll further down the list, you'll get all the red backgrounds. These are off-board components. Now our battery is going to be on wires, so we want to find an off-board battery, and that would be a type of power supply. And the type we'll be using, at least for now anyway, for testing, is a 9-volt clip battery. On that note, some of you may want to power yours off an old mobile phone charger or something similar, but I'll talk to you about that in a future lesson. But for Circuit Wizard, we'll just put one of these guys in, okay? All I did there was join the red wire to the plus, the black wire to the minus, press play, and just confirm everything works, okay? Right, that's the computer's version. You're going to get a screenshot of that as well. So drag a box around it, right-click, copy, paste it onto here. Because what we're going to do is a kind of before and after here. We're going to see what the computer can do versus what a human being can do. And that's what I'm going to be assessing you on. So, this circuit works, that's fine, but it's quite large. You all know how big one of these smoke alarm batteries is, and this is about, what, 2.5 times the size of that. We should easily be able to fit this circuit onto a footprint the size of that battery, and that's kind of your goal today. Right, now to really upset you, actually I'll just show you a couple of things before we go on. If we press play, don't forget you've got these options down here on the left, like current flow. This is quite useful because when you activate the circuit, you can see the paths the electricity is taking, and also if you build yours and it doesn't work, you can use this to kind of debug and find out what's gone wrong. Anyway, what I would advise for the next step is go to normal mode, and we're going to delete every connection the computer made but leave every component behind. So that means select a part on the screen, say there's background, and press delete on your keyboard. Select this border, delete. Each of these tracks we're going to delete. If you make a mistake, just do Control Z, by the way, that'll bring you back. Delete the tracks. Okay, and I know you might be thinking, why are we doing that? Well, we're going to do better than the computer. All right, and I don't want you cheating as well. Okay. Something else we need to do here, the grid. You'll see at the moment the components snap to the grid, these dots. All right, you're going to find in a minute that that's too big a gap. So I'd like you to go down to the bottom right here, where it says 0.1 in, and set it to 0.025. All right, you'll see the grid has got a lot smaller, and we can move things a lot more finely. Okay, my first recommendation. We're trying to build this. Now, obviously, they look very different in terms of how the components are, but what's important is what connects to what. So, for instance, the plus end of the battery connects to one end of my potentiometer, so on and so forth. I'm going to try and orientate things as close to this picture as I can. That's going to be step one. It will make it easier to join them together. So you may want to follow my lead on this. I'm just going to temporarily delete the battery. So I know my LDR goes on the left. I know this potentiometer goes like that. I'd recommend you turn your potentiometer around, and you'll see why in a minute. I've got a 1K resistor that I've just turned sideways, and I did that with these two buttons, and that goes in the middle there. Yeah, okay, so basically get the components sort of laid out as the picture, alright? So I've got the 108 next to the transistor, the 51 below it, then the 100, then my 3 LEDs all pointing down. Yeah, okay. Now, if you're not sure, for instance, which way to point the LED, so I said point down. If you hover on the legs, you'll see it gives them names. So this side of the LED, the base of the triangle, is called the anode, and the pointy end of the arrow, if you like, is called the cathode. So I want the cathodes all pointing to the bottom. These are my LEDs. Same deal here. If I hover, that's the cathode, that's the anode. So what we're saying is the flat side of my LEDs should all be pointing down. There we go. I know the resistor that went in front of them was that way. The only two you'll have to sort of follow my lead here with is the transistors. Well, actually you don't, but ignore that. If we look at the transistors, this leg on each transistor is called collector, and they both need to go up and over to the positive. So I'm going to put the collectors facing up. So that's the collector, this one on the left, rotate it right, and then I'll confirm I've got the collector here. Alright, so I hope you can see what I'm doing there. I'm just sort of, and remember you can select multiple things at once. I'm just sort of moving everything roughly as it is on the picture. Okay, good. That might be a good time for a screenshot. So drag a box, you know the deal. Drag a box, right click, copy and paste, put them in order. Okay, don't worry about typing on this yet, we'll do that later. That'll be your homework, you lucky people. Anyway, right, now we're going to start making some connections. So this is a bit where you've got to keep going between this picture on the left, the circuit diagram, and the PCB. So I suggest you start from one side. So we've got the plus end of our battery joins to several places. It joins to one end of the variable resistor, and it joins to the collector and the collector of both transistors. Here's the plus end of my battery, here's my variable resistor, here's the collector, here's the collector. So you're going to go up here, get the red track tool, and start here, a bit like in doing a diagram, click every time you want to turn a corner. Okay? Right. Now if you want to stop using the track tool, just right click on the mouse and it will cancel it. Okay? So for instance, that's what I wanted to do here, because I'm going to put another track like that. Now when you're making circuit boards, at least to start with, we try to draw nice 90-degree straight lines rather than diagonal lines. It's a bit easier to make it match this and easier to understand. Okay, so I've done this whole top row. Right, the other end of my variable resistor joins to my LDR, and it also joins to the left side of my 1K resistor. Now you might be looking at the variable resistor and going, hang on, this has only got 2 connections, yet on my one here it's got 3. You're not going mad. That is true. I don't really have time to explain why that is in this video, but you only need to use one of these legs. One of them will deliberately be left blank, okay? So I'm going to pick the one on the left, and one end of it connected to my LDR, which is here, and the other bit connected to my 1K resistor. Alright, and just remember, this is just a piece of metal, it's a conductor, it doesn't matter where you connect. I mean, pick the bit that lines up easiest, but doing that, for instance, is exactly the same as doing this, or exactly the same as doing that. Alright, it's all connected to the same place. We just tend to pick the path that looks similar. Okay, right, so I've done that. Now I've got the other end of my 1K resistor goes to the base of my transistor. So this is my small transistor, this leg is the base. Now what some of you might be tempted to do is go, alright, the easiest route would be like that. And then you'll get to a problem, because if we look now, we'll see, alright, I've done this, but now my leg called the emitter needs to connect to the base of the other transistor. Here's my emitter, here's the base of my other transistor. You may do one or two things. You might go, oh, let's do that. Now, unfortunately, that is like an illegal move in electronics. You cannot cross a red track over a red track, because that would cause what's called a short circuit. What you'd have to do is find a path to that connection without crossing this line here. Now, there's several ways of doing it. You could do the really long way. You could go round here, through this resistor, through here, up there, and like that. Or, and just entertain me for a second here, just delete that. You could change how you routed this one. So I'm just going to delete it. I'm going to come up and through the chip like that. Sorry, through the transistor. And then I'm going to take my emitter to my base that way. And I think you'll agree that's much neater. Now this is where things get a bit tricky. That obviously looks slightly different to the connections on here. On the picture, the base is on the left, but in real life, the base of the transistor is on the right, and you have to go underneath it. The most important thing, though, is that you do not make red wires cross like that. If you do that, it won't work. Alright, so we've done that. We're going to now move on to, so I've done this, done that, I've done pretty much all this top end. The transistor connects to the 100 resistor, and the 100 resistor connects to all three anodes. All good. So, here's my transistor, here's my 100 resistor, that was an easy one. These must be the anodes, because I spun them around that way already. Okay. Happy days. Right, and we're very nearly there. So we've done all of that lot now. All we've got left to do is put all the cathodes and the bottom of the LDR, they all go back without anything in the way to the negative side of the battery. So here's the negative side of the battery. So all of these guys, I'm just going to draw a line through them like that. Back, and the LDR goes back to the negative side of the battery. Okay, remember, it could go down, but equally doing that would be exactly the same connection. Alright, I'm going to leave it how it was. Okay, when you think you've made all the connections, your next step is to test it and check it still works. So plug your battery back in, press play, and check that when it's dark they're on and when it's light they're off. Okay, current flow will just confirm that. You'll see it travels where we want. Now just to show you the kind of problem I was talking about, if for instance I accidentally joined this to here, alright, I don't know why I would, but I've got a wrong connection. No, that will still work, actually that was a bad choice. So I accidentally joined this round to here like that. If I press play now, it won't work. And if I look at current flow, you'll see it's because the electricity is taking that new path back to the battery. Alright, electricity is basically just like a lonely puppy. It's always trying to find its way back home. That was a really sad analogy, alright, but it's trying to find the easiest path back to negative, back to the battery, if you like. And if you give it one, it will take that easy path. Okay? Right, when it works, take a screenshot as to prove that you've done sort of the level 1 bit. Okay, put that in your PowerPoint. So you should have about 4 by this stage. Right, and now we're going to go on the process of miniaturization. This is the bit where I'm going to leave you sort of on your own. I'm going to show you the methods. and then I'm just going to kind of do it. But there is more than one way to make this small. Basically, it involves pulling things closer together but keeping an eye on what they were connected to, and sometimes rotating components and sometimes needing new paths. But I reckon I can fit that onto an area smaller than that battery, and that's my challenge. Okay, so here we go. Right, the way I like to do it is I pick an object in the middle of the board and imagine it's like a black hole, and black holes suck everything towards them. Okay, so this stays fixed, but I'm going to start pulling things closer towards it. So I'm going to pull my potentiometer down, and then I'm sort of thinking, well, there's a bit of wasted space here. Maybe, I know that this needs to stay connected to there in a second, but if I rotate it clockwise and put it here, I'm going to put that connection back up to positive back temporarily, and then I've got to watch out for this, look, because that is connected to this leg, so I need to pull this out a little bit. You can either delete the track and try it again, or you can right click and add a node, which gives you a point to reposition. Okay, good. And I know that this needed to connect to my resistor, but I want to get my LDR up closer, so it's getting sucked towards the black hole. So what I might do is, rather than connect that straight across here, I'm going to delete it there, and I'm going to bring this path up through here and join it on there, which is exactly the same. If you don't believe me, press play every now and again, check it still works. It's always good, every couple of moves you do, check it still functions. Now that I've moved that wire out the way, I can move my LDR up a little bit. Alright, you'll notice things like this, you'll need to reconnect some connections. Okay, and now I'm thinking, well, hang on, why do I need to go around the houses here? Why can't I actually just delete that? And rather than going up round there and round, why can't I just kind of put that connection back here? Alright, so I've got my LDR nice and close to everything here. Right, now you don't want to go super close because you'll have trouble soldering. If you're in any doubt as to how big this is, just move this out of the way. If you zoom out to 100% on the screen, this is the actual size of your circuit board if you were to reach out and touch it. So as you can imagine, putting things super close is going to get a bit tricky, but I want you to try your best anyway. So there we go, we've done that. This is still a black hole pulling everything towards it, so next on the menu is my transistor. Now we've got to be a bit careful here. We know that those connections have got to be preserved and not touch anything else, so dragging it has caused all sorts of problems. So bit by bit, move things back how they are. That stayed there. I've got to get, this guy has got to get back round to that without crossing. So if I'm careful, I reckon I can come up through there at an angle. Maybe one more. There we go. Okay, I'm not connected to anything. I'm going to move this guy up a little bit more. Maybe, actually, no, I'm not. I'm going to move it sideways a bit. And this is just an experience thing, but alright, so that's closer together. Now I can bring this closer together. Okay, not touching, but fairly close. And actually, what I can start to do now is shrink that whole top half. Right now I've brought all this lot to the same vertical height. There's no need for this bar to be all the way up there. It could come right down to here. That could come right down to there. And I hope you guys can kind of see what I'm getting at. Alright, that is all the same connections I had before. This is still at positive, this is still connected to the positive. That's still connected as it was, but I've saved a ton of space vertically. We're already getting pretty close to the battery in terms of size. Press play, check it still works. All good. And now I'm going to start working on the rest of the board. So this left side is looking pretty spacey at the moment. So I'm going to pull my battery over here. But hang on, what might be better is just putting the battery up there. Okay, don't need all that. Bring that in this way. Don't need all that. And I've saved a ton of room off the left side of the board. This just needs to connect to here. So let's just put that on there. Go. And now all that's left to do is compact the left hand side. Now for this one I'm going to start rotating some components. So I'm just going to temporarily, I know this resistor needs to connect to these guys here, but I'm just going to break them away for a second, and I'm going to take my resistor, rotate it and tuck it up in here where we've got loads of space. Right, and that means I can pull this wire in like that. Now because I had a good memory, or if I'd forgotten I could check my diagram, the spare end of the resistor needs to go to those three connections. Well, get rid of that. Let's select all of those, move them up into the gap here. While I'm at it, I might as well pull the whole top area down and make it more compact. Oh, God, excuse me. Right, okay. Okay, you will have a lot of clicking to do. And that end of the resistor had to connect to these three guys here. Alright, those three there all had to go to negative. Now I could go down and back here, but actually this point on the LDR is the same place. Alright, going to there is exactly the same as going down and round. It goes directly back to negative. So all of that there is a waste. Bring that up. Okay, and there is my circuit. Does it still work? Yes, it does, because I'm a legend and big-headed. Alright, and there we go. Now, there are a few more things to do. That's probably more than enough for the first lesson. You know, so take a screenshot now before you do any more. So do that. Right-click, copy, and then stick that in your PowerPoint there. Okay. Right, I'll add a second video part in now. Although that looks a lot smaller, if we compare it size for size, it's nearly a quarter the size of what we had before. Although it is smaller, there's still work to be done on this. We've still got to add labels and borders and things called strain relief holes and some other things to make manufacturing it a bit easier, but that'll do for now. Just if you're interested, if you click on artwork, at the moment, that's what your circuit board will look like after manufacture. In the next video, we'll be adding labels on, like your name. Oh, that was terrible, but you get the idea. But we're at 20 minutes already here, so I need to wrap this one up. All right. So if you can get that done today's lesson in one period, that would be amazing. Obviously, save your work when you're done.